from my previous experience, arguably the most damaging part of a piece of equipment's life cycle is the transportation.
Yep.
So as soon as it leaves the shop, all of a sudden it's no longer good. So if it's green tagged in the shop, tested, everybody's happy with it, we put it in a package, we FedEx it out or transport, however it wants to travel, then it comes back, never even seeing location. We still orange tag it, or we still consider it contaminated until we can prove that it's functional.
Yep.
It's the opposite of innocent until proven guilty. This is failed until proven functional. You know, we've walked around the office. We did a tour of the shop. We talked to the guys. We jumped in. You were part of one of our morning calls, or one of our meetings. But one thing that we didn't really talk about is the methodology of hardware.
Yep.
And the reason why this is near and dear to my heart is because, of course, I'm hardware.
Yep.
But I started in hardware from the operations side. So when cold bore started becoming a thing, we started manufacturing commercial application hardware. I was the guy taking the phone calls during the night, and I was the guy manufacturing the hardware and handling the coordination during the day, because we started off as a very small, multi-hatted team.
Yep.
So what happened is every time that I would release poor hardware, it would go out to the field, and the field hands would call me up 6, 7, 8, 9, 2 in the morning, whatever it is, and express to me their enthusiasm about the operational nature of the hardware.
Yep.
And you only have to get those phone calls 100, 200 times before you change what you're doing.
Yeah. Well, they're on the front lines, high pressure, right?
That's right.
So they're probably getting it from their client at the end of the day. So it's a big deal.
Yes, and their failure is our failure.
Well, it's your team.
Exactly that.
We are a team, I mean.
Yeah,
we.
Yeah. I throw them the football, they run the play.
Yeah.
That's how it has to work.
Yep.
So if the football's poorly inflated, hard times. So what we did was we started adopting this can-I culture. It's a constant, never-ending improvement.
Yep.
So a lot of people, and there's several different manufacturing design methodologies that we could go through, different engineering perspectives, et cetera. But this constant and never-ending improvement is it's never good enough, because you only get to see the hardware a number of times. Some of our stuff has been out operating in the field for 3+ years between services. Yep. How do you get it so it doesn't fail during that time? It comes in, and if you see a problem, maybe water gets past a gasket. We're not going to start up an engineering process. We're not going to do a design revision review. We're not going to have a committee meet and talk about this. No, if you see a problem, it's your obligation to fix the problem.
Well, so how do you fix it? So for example, you have a leaky gasket. Do you just fix that one unit, or does everything across the board get upgraded? Everything
across the board gets upgraded. So we call those manufacturing campaigns. Sometimes we have M&R campaigns, maintenance and repair, where you have a manufacturing campaign. In this case, we've probably executed 300 or 400 manufacturing campaigns across the board for all of our equipment. So the first thing is put the fire out.
Yeah.
Things are leaking, stop the leaking. The second thing is we look at the actual root cause of the problem. Is it because it's in a bad environment? Is it a one-of? What's the risk, the relative cost of the company, et cetera? And we come up with a long-term solution for everybody, and then we just go. So anytime that piece of equipment comes into the shop, we make that change on it. Like there cannot be a compromise of the quality of hardware that goes out to the field, because if we send to field a piece of hardware that fails, the capital cost of the company is just too high.
Even just explain to us what are some of the actual costs of doing a completions job, because these are big projects, and if one piece of equipment fails, there's a whole bunch of people sitting around not doing anything, which costs a lot of money.
That's right. I don't know how I can explain it better than you have.
Yeah.
The gentlemen or the folks through product have a better grasp of the total life cycle cost of completing a well. I can say from personal experience, though, something that's super neat. We have wells that are close-ish to us that are acid frac jobs. And I've been from the directional side on those wells drilling them, and they take a week-ish to drill. When you approach them and you go to frack them with acid, start to finish, a easy well to frack is about 3 hours, and the total cost of fracking versus drilling is easily a 10 times multiple. Wow. So there's a lot of cost. Drilling, I would average a drilling rig at $26, $36 a minute. Fracking, I can't tell you how that number breaks down, but I know it's a lot.
Yeah.
So if something were to happen where a cold bore system that people are relying on for data, for information, to make live decisions fails and it causes people to stand around, that's just not something that I can deal with on our infrastructure, on our image.
Well,
So
and you don't want to be that guy. You don't want to be the company that the job is on hold because some equipment failed.
that's right.
So this gets into, I'm just thinking, we were in the shop, we were looking at a lot of the testing that happened. So when a kit comes back, everything gets tested.
Yes, everything.
So what does that process look like? Because we got cables are getting cleaned, connectors are getting inspected, both on if it's the SIBs, the hardware,
Yep.
everything, and everything is getting tested. The SIBs, all the hardware gets tested.
Yeah, the SIBs, valve sensors, pressure sensors, cables, the electronics inside of the kit box, the laptops, everything comes in for a spa day. We call it a spa day because it comes in and it gets refreshed.
Yep.
And it's made to look as close to new as possibly can.
Yep.
But we have a couple of mottos and sayings in hardware. One of them is don't send to field failed equipment.
Yep.
As in, if it goes out and it has a likelihood of failure, we need to either replace it, we need to fix it, we need to put it in isolation, we need to give it a little timeout, spruce until we can understand how it's going to fail and how we need to go about resolving that failure before it happens.
Yep.
But we just do not send a field failed equipment.
Yep.
The other model that we have is test the equipment as if it's running in the field. Mm-hmm. So it's really easy to take, let's say, a valve sensor, take a multimeter, pin it out. Oh, okay, this valve sensor looks good. But that multimeter check against a valve sensor has no bearing on how the valve sensor actually operates.
So it's not really a valid test.
It's not a valid test.
Yeah.
It is a test that may find specific problems, but when you're looking at a pre-field release of equipment, you need to test the equipment as if it's running in the field. So stroke it, put it on the equipment that it'll run with in the field. And I'm not saying it's a direct one-to-one, but simulate as close as you possibly can a field environment.
Yep.
These types of things are the difference between, in my mind, and of course I'm the hardware guy, I would say this, but they're the difference between a successful company and a failing company. If we can prevent the issues, if we can present, and we can even call them hidden costs.
Yep.
So let's say we have a SIB and a panel and some valve sensors, and we take a failure. So not only that panel, and if it was a preventable failure, that panel needs to be packaged up, driven to FedEx back to the home base for spa day for repairs. The backup panel that was on location is now prime. There's no more backup.
Yeah.
We take a panel from our shop. Everyone has to stop doing what they're doing. Take another piece of equipment out of inventory or out of the lab, package that up, FedEx that down. Part of work, right? But then we start looking at why did it fail? How did it fail? How did it pass our testing? Do we need to revise our test process? We need to have meetings with the clients. We need to talk about how it failed, why it failed. The amount of toil that goes to properly close incidents, incident reports, equipment change request meetings are enormous. If we could just put a little bit more effort on the front side and not have that piece of equipment fail due to negligence, all of a sudden the company is just a lot more leaner than, well, what's the risk and probability of the failure, right? We've all heard this risk matrix.
Yeah.
Well, if we shift it all just one step to the side, it's just a cheaper company to operate. It's a more successful company to operate.
So the other day, Kevin was cleaning the valve position sensors, and there was a number of the sensors where the kind of the inner part, the stroke kind of piece that goes in and out, it gets bent.
Yes.
So sometimes, being out on some of these jobs, there's definitely an environmental challenge, right? Things get banged up all the time. But then there's things getting installed, they're getting uninstalled. It seems like the reality is that equipment is going to get beat up. That it's a guarantee that there's always going to be problems. So ensuring that there's always the proper maintenance that's happening all the time, because you can't just say that this is going to be fine. You can't just assume that everything is fine when it comes back from a job.
No, that's exactly it. Actually, from my previous experience, arguably the most damaging part of a piece of equipment's life cycle is the transportation.
Yep.
So as soon as it leaves the shop, all of a sudden it's no longer good. So if it's green tagged in the shop, tested, everybody's happy with it, we put it in a package, we FedEx it out or transport, however it wants to travel, then it comes back, never even seeing location. We still orange tag it, or we still consider it contaminated until we can prove that it's functional.
Yep.
It's the opposite of innocent until proven guilty. This is failed until proven functional.
Yep.
And that's really the core of cold bore hardware.
Where does hardware kind of go? Like, how does hardware kind of grow with cold bore? Do you have some thoughts? And because we've talked a little bit about the Dish in a Box, which is a really cool project that you guys have been working on.
Yep.
So where do you see hardware adding more value for customers, or like where do things kind of go maybe over the next year or two? Do you think?
Yeah, we are. I'm not going to use the word crossroads. It's a little cliche.
Well, it kind of means that, okay, we have a really big decision we have to make depending on the direction, but there's maybe a couple different opportunities, perhaps.
Absolutely. So there's many different gradients of success. You know, we're pushing to require less operational toil on pad.
Yep.
So the idea, we're trying to make more and more smart equipment. So that we can handle it, maintain it, communicate with it without human intervention.
So does this essentially mean, does smart mean wireless, or does smart just mean it doesn't need to have a physical person interacting with the hardware?
It's a different step. Smart means, and I'm not going to use the word self-aware, but it knows its own name.
Okay.
Now, there's nothing that we do from hardware that's one-sided. Like, we never just say, oh, we're going to give this a serial number, and that's it. There's always going to be 2 or 3 or 4 benefits, because there's never just... You can't change something, send it out, and then bring it back to make another small change. So we try to make meaningful changes one at a time.
Okay.
So in the case of smart, we're digitizing, just as we're digitizing frac fleets, digitizing the pads, building our layers of data, etc. We're also adding, and I'll call it intelligence. It's not really that smart, but we're also adding intelligence to our equipment. You know, what's your name? Where are you? Who do you report to? Where are you installed on? If we can ask digitally our equipment this information, then we don't have to ask our field techs this information.
So basically, with all the hardware that's deployed on site, so the smart aspect is that it can essentially ping a signal and says, this is what I am, my serial number. This is where I am on a particular location, and other data that is available can get basically sent. So this kind of almost seems like a bit of an asset tracking aspect.
That's exactly what it is. So it's kind of under the guise of asset tracker, but you know, we're kicking off, or we're implementing something we call pad scraper. And pad scraper is the ability to scrape the pad of relative or relevant operational information that may not be our core service offering to the client. So in the whole objective, 10,000 feet down the road, if we actually choose to go this entire direction, would be to say, how many strokes has a valve sensor had over its life? What's the average failure rate of strokes when you're installed high up on a frac tree instead of low down on a frac tree? Where are the most common locations for a pressure sensor to fail? But it's all tied back to the serial number. And instead of it being things like a equipment traveler log where a field hand is filling that out by hand, when you have 100, 200 pieces of equipment on pad, 200 traveler logs is an unmanageable amount of paperwork. So we're automating the whole thing. So the idea is, as part of the workflow of setting up the equipment on pad, the signatures or the locations or the information we're telling the equipment, it remembers and records in the asset tracker. So pad scraper.
So at the end of the day, though, maintaining the equipment, ensuring the functionality and the operation of the equipment, maintaining that you know where things are, at the end of the day, it sounds like the benefit to customers is they're not going to get an increased price because you have lost equipment or you're sending equipment out that is not properly maintained. At the end of the day,
that's exactly it. And as we approach people being less and less on pad, anytime a person has to go to pad due to a failure is a call out. Somebody's paying for the call out.
Yeah.
You know, the field tech must get paid for his or her trip. So somehow that price exists. Every time we can eliminate or reduce a call out requirement is awesome for hardware. But these are internal tools. You know, to fully answer the question, where else can cold bore hardware go? We are internally discussing rentals, like a rental model. So instead of it being our field techs who are running, maybe there's a factory provider who would benefit from digitization, and they can unlock a little bit more of their market by renting or purchasing equipment from us and basically selling our services, but through them, from them
Yep.
to their clients. And maybe it'll open the door for cold war. Maybe it won't. But we still increase our digital presence on location. Like we need to elevate the whole industry to digital for our smart pad to truly shine. And whatever method we go about doing that is good for us.
The hardware really, I guess, is the means to an end right now to be able to connect to capture all of the information that you're trying to capture. So that might change and evolve over time too.
Absolutely. Not only that, but there are so many other third-party data captures that we haven't done. Like we kicked off a project, Noise and Weather, with one of our clients, which was fantastic. We're recording noise, so they're inside of some compliance regulations, and we can validate that to protect them from litigation, lawsuit, etc.
Yep.
And maybe it helps them understand their operation a little better. Maybe a pump will start making a pinging sound when it starts breaking, and you can pick that up with our or with our noise monitors.
Yep.
But I think looking at other pieces of information as it surrounds frac, like everybody looks on their phone and has a lightning tracking app. Well, why isn't that in SmartPad?
That would actually be a good indicator of, hey, lightning strike within 3 miles, time to shut down.
That's right. And they do that, but they do that with a suite that's outside of SmartPad. Mm-hmm. And so as you start taking all of these independent pieces of data and bringing that into a centralized location, not only do you have potentially better accuracy, you have better notifications, you have the ability to action on it, but then 2 years from now, when an engineer is looking at your data set, they can say, why did you shut down here? I see a critical path entry. There's some electrical lightning issues. Oh, okay, yeah, and I see there was a lightning strike within 10 miles. They shut down for that. But there are ancillary things that can happen because of that. Maybe the sand trucks, they stopped driving because of a lightning shower. Maybe there was a lightning strike that was relatively close to pad, and then over the next 2, 3, 4 weeks, electrical equipment started failing because of some things that were happening.
So really just another way of adding more kind of metadata into the overall data set to provide more contextual information as to what else was also going on during the job that may not be related to the actual fracking of it, but other environmental conditions or other things
Absolutely.
that can be tracked as well.
Stuff that's taken as commonplace, or I instinctually understand today that has happened. A year from now, 2 years from now, when you're looking at a chart to understand the operation, just won't be present.
Yeah.
So if we can provide that in one place, the value of our data is exponential at that point.